Good morning, students. Welcome to the class. In the previous class, we had completed Unit 4. Okay. Today we have discussed Unit 5. We started Unit 5. Unit 5 is your two-dimensional viewing. Okay. So, in this chapter, we will study viewing pipeline and clipping. Okay, so today we discuss in this class viewing pipeline and window to viewport coordinate transformation. Okay, so let us discuss in detail viewing pipeline. Okay, so viewing pipeline. Okay, in the viewing pipeline we discuss some new terms: window, viewport and viewing transformation. So first we discuss what is window. Okay, area selected in world coordinate for display is called window. It defines what is to be viewed. Okay, that means when the image is displayed, it is known as a window. Okay, then next point is viewport. Area on display device in which window image is displayed is called viewport. It defines where to display. That means the whole object which is displayed in the screen, it is known as window. And viewport is the portion which you want to display in a device. Okay, or in another screen device, which portion you want to display. A display device, the area which you want to display of the window image on a display device is known as viewport. Okay, in many cases window and viewport are rectangle. Also other shape may be used as window and viewport. Okay, in general, finding device coordinate of viewport from world coordinate of window is called as viewing transformation. That means the device coordinate of viewport from world coordinate of window is called as viewing transformation. Okay, sometimes we consider this viewing transformation as window to viewport transformation, but in general it involves more steps. Okay, for example, in this figure, this picture is your world coordinate. Okay, but in this picture we only clip out this portion, and this portion we clipped and display in another device. Okay, the another device where we want to display is known as viewport. This one is your viewport. Okay, another device where only this portion we want to clip and display here. So this one is your viewport. Okay, now we see some steps involved in viewing pipeline. What are the different steps? Okay, first is your construct world coordinate scene using modeling coordinate transformation. Then it will convert to world coordinate. It will convert world coordinate to viewing coordinate. Okay, after that it the map viewing coordinate to normalize viewing coordinate using window to viewport specification. Then or finally it map normalized viewport to device coordinate. Okay, that means first modeling coordinate means MC or MC construct world coordinate using MC. MC means modeling coordinate transformation. It will converted into the world coordinate. Okay, world coordinate then convert into viewing coordinate or VC. After that viewing coordinate will be converted using the normalized viewing coordinates. Okay, then finally we display in a device coordinate. Okay, so this one is your 2D viewing pipeline. Okay, as shown in this figure, we also construct the world coordinate scene using modeling coordinate transformation. After this we convert viewing coordinate from world coordinate using window to viewport transformation. Then we map viewing coordinate to normalize viewing coordinate, in which we obtain the values in between 0 and 1. Okay. At last, we convert normalized viewing coordinate to device coordinate using device driver software, which provides device specification. Okay. Finally, device coordinate is used to display image on the display screen. Okay. By changing the viewport position on screen, we can see image at different place on the screen. Okay. And by changing the size of the window and viewport, we can obtain zoom in and zoom out effect as per requirement. We also enlarge it, or we also reduce it, or zoom in, zoom out. Okay. Now fixed size viewport and small size window gives zoom in effect, and fixed sized viewport and larger window gives zoom out effect. Okay. So viewports are generally defined with the unit square so that graphics packages are more device independent, which we call as normalized viewing coordinate. Okay. So this one is your viewing pipeline. In the viewing pipeline, we have learned what is window, what is viewport, and what is viewing transmission, and what are the steps of 2D modeling viewing, 2D modeling coordinate. Okay, this one is a 2D viewing pipeline. Now let us discuss viewing coordinate reference frame. Okay, in this figure, in this figure, this figure is your world coordinate, and this figure is your viewing coordinate. Okay, in this world coordinate, this one is your x-axis, this one is your x-axis, and this one is your y-axis. Okay, and in this x-axis, y-axis, when we rotate this object, generally we only horizontally or vertically line we will place. If we rotate this and in this way x-axis and y-axis if we draw, then it will show like this. Okay, so that means in the world coordinate we rotate this axis and looks the picture how it look like. Okay, and this one is your viewing coordinate. In viewing coordinate, this is your y-axis and this is your x-axis according to your world coordinate. But when we rotate this axis, this one is your y viewing axis and this one is your x viewing axis. So in this way the picture which we looks in this world coordinate, this one is also looks like in the rotation wise it will viewing coordinate. That means in this figure we explain a viewing coordinate frame is moved into coincidence with the world frame in two steps. First step is translate the viewing origin to the world origin, then rotate the two align the axis of the two system. First one is translate the viewing origin to the world origin, then it rotate the align axis of the two system. Okay. Now we can obtain a reference frame in any direction and at any position. Okay. For handling such condition, first of all we translate reference frame origin to standard reference frame origin, then we rotate it to align it to standard axis. First we translate the reference frame origin to standard reference frame origin, then we rotate it and align it also to its standard axis. Okay. In this way we can adjust window in any reference frame. Okay. This is illustrated by the following transformation matrix, where T is translation matrix and R is rotation matrix. Okay. Okay, that means M world coordinate and viewing coordinate equals to R dot T. R is your rotation matrix and T is your translation matrix. In this way you can find out the transformation matrix. Okay. Now let us discuss what is window to viewport coordinate transformation, how it can be processed, okay, or how it can be viewed. In this figure, this one is your world coordinate, this one is your viewing coordinate. Okay, this one is your world coordinate, this one is your viewing coordinate. In this world coordinate, this one is your clipping window. Okay, in this clipping window, this point is known as XW and XWYW. That means this point coordinate position is XWYW. Okay, this one is your X axis, this one is your Y axis. In this X axis, this one is your XW min, this point is your XW min and this is your XW min. XW means X axis window or X axis world coordinate. So this way we write here XW max and XW means this, and this one is your YW min and YW max. Okay. So this portion, clipping window portion, clipped and viewing in the viewport or another device. So here only this one is your X axis, this one is your X axis and this one is your Y axis. Okay, in this X axis, this one is your XV, that means X viewport and Y viewport. The XV mean, this point line is your XV min and this one is your XV max, and in the Y axis this one is your YV min, this one is your YV max. Okay, so this figure displays the window to viewport mapping, how it can be mapped from window to viewport. Okay, let us discuss. A point at position xw, yw in a designated window is mapped to viewport coordinate xb, yb. That means here this point is xw, yw in the world coordinate position, and when this window is clipping and display in the another display device, which is our viewport device. Here this one is our xb, yb. Okay, so that the relative position in the two areas are the same. Okay, a point at position xv, yv in the window is mapped into position xv, yv in the associated viewport. Okay, mapping of window coordinate to viewport is called window to viewport transmission. When window coordinate to viewport coordinate mapping, this process is called window to viewport transformation. Okay, we do this using transformation that maintains relative position of window coordinate into viewport. That means the center coordinate in window must be remain at center position in viewport. Okay, the window coordinate center position must be remain same at center position in viewport coordinate. Okay, so we find relative position by equation as follows. Here that means the point which one is xb, yv, and here xw, yw, same point, the position also same, but this one is your world coordinate to view coordinate mapping. So that means the equation is xb minus xb mean. Xb means x viewport. Okay, xb minus xb mean by xb max minus xb mean. Xb max means x viewport max value minus x viewport mean value equals to xw minus xw means. Xw means x window. Okay, minus x window mean by xw max minus xw mean. Xw max means x window max value minus x window mean value. Okay, in the same way this one is your according to your x axis. According to your y axis is also same, yv minus yv mean by yv max minus yv mean equals to yw minus yw mean by yw max minus yw mean. Okay, so solving by making viewport position as subject we obtain, that means here xb equal to xb mean plus xw minus xw mean into sx, and yv equals to yv mean plus yw minus yw mean. Okay, into sy, where sx and sy is known as your scaling factor. Sx is xv max minus xb mean by xw max minus xw mean. So in this way sy is also sy equals to yv max minus yv mean by yw max minus yw mean. Okay, so after that we can also map window to viewport with the set of transformation which include the following sequence of transformation. What are the sequences? Sequence of transformation. First one is perform a scaling transformation using a fixed point position of xw mean, yw mean. that scales the window area to the size of the viewport. Okay. Second one is translate the scale window area to the position of the viewport. Okay. So in this way we can map the window to viewport according to the following steps, sequence of transformation steps. Okay. For maintaining relative proportion, we take Sx equal to Sy. That means scaling x equals to scaling y. In case if both are not equal, then we get stretched or contracted in either the x or y direction. If both are not equal or not same, then we get stretched or contracted in either x or y direction when display on the output device. Okay. Characters are handled in two different ways. Okay. One way is simple maintain relative position like other primitives. First one is your maintain relative position like other primitives, and second one is maintain standard character size even though viewport size is enlarged or reduced. Okay. So number of display device can be used in application, and for each we can use different window to viewport transformation. This process or this mapping is called workstation transformation. Okay. So in this example, this one is your normalized space. Okay. That means window S1 and window S2. So here two objects are there. When this particular viewport size, when you clipped out and display in different monitor, so first one is your window S1 viewport, second one is your window S2 viewport. That means one normalized space we can view the object in different monitor or different device or different workstations. Okay. As shown in figure, for different figure, two different display devices are used. We map different window to viewport on each one. Okay. Let us discuss what are the advantages of viewing transformation. First one is world coordinate system is selected. There are three advantages of viewing transformation. First one is world coordinate system is selected suits according to the application program. Second one is screen coordinate system is chosen according to the need of design. Okay. Third one is viewing transformation is selected as a bridge between the world and the screen coordinate. Okay. So this one is your viewing pipeline and window to viewport coordinate transformation. Okay. So in this class we cover in viewing pipeline. In the viewing pipeline we learn what is window, what is viewport, and what is viewing transformation. Okay. And also learn the window to viewport coordinate transformation. Okay.